Okay, so we're back. You do realize this has been a just a stream of videos to cover two problems. So you can see how this is quite demanding of our time. I really quickly, I do want to. You probably noticed it in the previous video. So I should have had a T right here, and it made sense because everything should have been in terms of T. Just in my, I guess, in my excitement, I had a Y here. So, but anyway, nevertheless, so at this stage, what we're going to do is we're just simply going to plug in for y, y prime, y double prime, y triple prime. And then we're going to use that to see if we can actually solve for the a, the b, the c in our form of y. Right, and so that's really what I'm doing right now. This is me plugging in for y triple prime, y double prime, y prime, and y. And then all I'm going to do is, when moving from second step to third step, but just imagine me changing the sign so that I can drop those brackets. And then I want anything with t squareds to be clustered together, and anything with t's to be clustered together, and then anything with just constants to be clustered together. So, okay, so in this case, let's take a look at the form of our answer. Let's start with the negative t squared. Now, remember, I'm trying to solve for a, b, and c, the coefficients, right? That's why they call this the method of undetermined coefficients, because we have not determined what the coefficients are yet. So in this case, I'm going to take a t squared and set it equal to negative t squared, right? Because what I know is I need a t squared to equal negative t squared. And in that case, in order to accomplish that, I would have to have an a that is equal to negative 1. Okay, now let's take anything with a t attached. So that would be negative 2a t plus bt. And I know that that's going to have to equal negative 2t. Of course, the only little caveat here is I actually know what a is equal to in this case. A is equal to negative 1. So I have negative 2 times negative 1, so I have a positive 2t plus bt is equal to negative 2t. Okay, so subtract 2t from both sides. bt is equal to negative 4t, and that means that b is going to be equal to negative 4. And now lastly, since if you, again, looking at the solution region here, so notice I have t squareds, I have t's, but I don't have any constants. So I know that this portion here is going to have to zero out. So let's go ahead and do that now. So negative 2a minus b plus c, that's all going to have to zero out. But what the good news is, I already know what a is, and I already know what b is. So I have negative 2 times negative 1, and then I have a negative 4, so I end up with 6 plus c is equal to 0, or in other words, c is equal to negative 6. Okay. Now, remember that the original y that I chose up here was at squared plus bt plus c. All of that work was so that I could figure out the coefficients. So with a equal to negative 1, this is negative t squared minus 4t minus 6. Now, what is that? What is that? That is the particular solution to the non-homogeneous part. So that's the part that I'm going to have to add back in. Okay? So let me grab that. So remember that this right here, this is the general solution to the non-homogeneous equations. And how do you get that? Well, it's just the sum. It's the sum of what? First, it's the the general solution to the homogeneous portion, right here, plus the particular solution to the non-homogeneous. So all I'm doing now, what you're seeing is I already had from previous work, from previous video, I already had the general solution to the homogeneous, but I needed to add in the particular solution to the non-homogeneous. And voila, I have my x of t. Okay, so that's the general solution to the non-homogeneous equation. So now, we're not too far from being done, but we do have a little bit more work. So normally, what do you, so when you're doing an elimination method, normally when you find x, what do? You take x and you plug it back in to find y, right? So I want you to look at, so this was the original problem, and I want you to notice a problem here. So for example, I can, so looking at my two equations, only the top equation has y, right? So normally what I would do is I would solve for y, and then I would plug this in for the x's. But can you see a problem? Right? I mean, if I solve this for y, that's not the problem. I can do that. But do you see that what would be left on the right side of the equation if I solve this for y? Do you see how I would still have a y prime? And that's not going to help me, right? Because I know what to plug in for x. That's easy. Okay, I can plug in this right here for the x. And then I can take the derivative of that, or in this case, the third derivative of that. I can plug in for x, triple prime. That's, again, not a problem. But the problem is I don't know what to plug in for y prime because I don't know what y is. So how do we get around this? Well, let me just show you a trick, okay? And the trick is to first take this original problem, just like we've already done before, and get it back to the differential operators. Okay, so this is what that original system would look like in differential operators. And now I'll show you the trick. The trick you have to be able to get to here for this trick to work. So what I'm going to do is I'm simply going to add. Are you ready? So if I were to add, let's go down the line. Let's start. So this would be d sub 2 minus 1. And that would be, I said add, I mean subtract. I'm just simply going to subtract. Minus d minus 1. And all of that is in terms of x. So I said add, but I meant subtract. So, okay, so we subtracted the x portion. Now let's go ahead and subtract out the y portion. So in that case, we would have plus, and then we would end up with, let's see, this is kind of clumsy. So I would have d sub 1, or no, so d plus 1, and since I'm subtracting, I would want to minus d, and all of that would be in terms of y. And the last thing to do is just say negative 1 minus t squared. Okay, now the reason why this is going to be helpful is because what I'm going to be able to do is solve for y in the differential operator form. Okay, so let me go ahead and do this. I'm gonna clean this up a little bit, and I'll show you what I'm talking about when I solve for y. So let me see if I can clean this up. Start with this part. So that would just simply be d squared minus d of x, and then plus, well, you notice that you're taking a derivative and then canceling your derivative by the opposite of the negative derivative of t. So with respect to t, so that ends up just being 1. So 1, which is a function of y. All right, so I've cleaned it up a little bit. And again, why did I decide to subtract instead of deciding to add? Because I knew that I had a differential, a positive differential here operator and a positive differential operator here. So I knew that if I subtracted, my d's would cancel out like they did here, and I would just be left with y. So now I can actually solve this for y. So, okay, so in other words, we're going to take this portion here, we're going to bring it over to the right side. There's two reasons why I like this method. So let me go ahead and write what would be left at that point. So I would finally have y left on the right side of the equation. I would have to subtract my differential operators with respect to x. And what I'm going to do in just a second is I'm going to change those signs. Okay, so that would leave me with y being equal to, now I would have negative d squared plus d, all operating on x, and minus y minus t squared. Okay, now do you agree with me at this point that I have solved for y? Okay, then just like when when you're doing any type of system, you plug in for x so that you can finish solving for y. So I am going to, at this stage right here, if you want to see what I'm doing, I'm plugging in what we got for x. Okay, so we still have, I'll have to go back just so I can show you. So basically, when you take that result of what we got for x and plug it here, this is what we have. Now, we would still have to start working those differential operators, right? We work from right to left, meaning we start here, take the derivative, then we move on to the negative d squared. But I hope that that makes sense on just this part, how I was able to solve for y and then substitute in for x. Okay, so in this case, really the only thing left to do is to just basically take the derivatives inside here, right? And then we have the second derivatives and so forth. And this is not that this is super easy. I mean, you can see how you have product rules here, right? So this first stage is me taking care of the first operator d. So you can imagine if you follow my lines here. So the derivative of c sub 1 e to the t is just c sub 1 e to the t. Now the derivative of c sub 2 t e to the t, well, that's a product rule, right? So that would get me to here. And then I would have the derivative of c sub 3 e to the negative t, which is just negative c sub 3 e to the negative t. Then finally, I would have the derivative of negative t squared is just negative t. The derivative of negative 4t is negative 4. And finally, the derivative of negative 6 just zeroes out. Okay? So I would have one more round of operators to do, right? Because I would still have to do this. Now I would have to take, and I'll go ahead and write that here. So now I would have to have y of t, and the last bit that I'd have to do is this negative a second derivative here. So I would have to take the second derivative of this. Okay? And now I'm not going to work through all of that. I mean, it's not that bad, truthfully. Yeah, so I mean, I guess, and then you'd have a lot to combine. You'd have a lot of things that you would have to combine inside there. But with this, I don't feel like I'm cheating you too much by because you know how to take derivatives. So when everything's said and done, what you would end up with is y of t being equal to negative c sub 2 e to the t minus 2c sub 3 e to the negative t minus t squared minus 2t minus 3. So at this stage, you have x and you have y, and you have solved that system. And you can see that solving a system for differential equations is, well, it's not as straightforward as solving a system of just linear regular equations. But what I would suggest that you do, okay, because we don't have a whole lot more in terms of theory and material to go over for this final. I have one more section, I believe, one or two more sections. But what I would suggest is that you, well, on your own time, you should make sure that you can get from here to here. And then, since this is the only, this is the last, we only did 2 problems out of this whole section. If you want, you could, on your own time, since you need some practice, you should go back to this method and see if you can apply this method to the very first problem that we did here. Right? See if you can make it work. It would be a lot easier on that first problem than it was on this one. This one was quite demanding of our time. But we were able to get through it, and you now have x and you have y, and those are the solutions to this system of differential equations. So okay, we will call it quits. If you need me, come see me in office hours. Okay, I can go through this more in detail, but I think at least I hope that you can follow me through, or you were able to follow me through the majority of this. All right, take care.